In today's lesson, we're going to learn about rates, equivalent rates, and unit rates together. Now at this point, hopefully you've learned a little bit about ratios, so you know how to compare two different quantities or two different amounts of things. Now a specific type of ratio is something going to be called a rate, where we compare two types of things with different types of units. And then we're going to talk about things called unit rates, which are even a more specific type of rate, which is just per one of one particular unit. So first vocab word for today is going to be the rate, which is meaning that we're comparing two different quantities here that are going to have different types of units as opposed to the same types of units like we're talking about with ratios. So I think it's important to note that we're talking about different types of units here. All right. Now, what about an equivalent rate? Well, an equivalent rate is just going to be another rate that is written that is the same value as another type of rate. So when they have the same value. All right. And so basically when we have a rate, if you take the first number and divide it by the second number in the rate, if the two rates are equivalent, you'll always get the same value. All right. Next, we have a unit rate, which again, this is a specific type of rate, but this specific type of rate is when the denominator is 1, if it's written in fraction form, or we can just say it's per one of whatever that second unit is. All right. So if you have just say like $3 for 2 pieces of candy, that's a rate. But if you want it per one piece of candy, then it'll be $1.50 per one piece of candy. That would be the unit rate. Finally, we have a rate table. A rate table is kind of similar to a ratio table. So it's a table of values that's going to contain multiple equivalent rates. So each pair of units that go together are going to be the same value. But essentially, when we take a look at this, we're going to have a bunch of equivalent rates in there. And we're going to have the top row, if we have it written left to right, be the x-axis, and the bottom row be the y-axis. So you can graph these rates just like we were graphing ratios before. All right, so starting off with some examples here, let's talk about how to write equivalent rates here as well as a unit rate. So here in example A, we see that Ruhi buys 3 Dino chicken nuggies for $2.70. So clearly we have two different types of units, right? We have these Dino chicken nuggies and then we have money. So those are two different types of units. So this is not a ratio. This would be a rate instead because we're comparing two different types of units. So typically you would write the rates with money first. So we're going to write this in fraction form, but it's going to be $2.70, and that's for how many of these Dino chicken nuggies? Well, that's going to be for 3 of them. Since the money is already labeled, I'm just going to write 3 on the bottom because I think that's clear that that's not talking about the money. So that's the original rate here. So this right here is the original rate in the problem. Now, if you want to write an equivalent rate, you can do a couple different things. You can either multiply or divide top and bottom by the same value because that's essentially just using the identity property of multiplication. So for instance here, we can go ahead and multiply the top. Let's say we have 5 times the price, then we should get 5 times the chicken nuggies here, right? So if we go ahead and do that, then 3 times 5, that would be 15 of these Dino chicken nuggies. And then for this part of the unit, if you'd like to just use a calculator, feel free to do so. If you don't have a calculator, then just go ahead and multiply it by hand. But if you take $2.70 and multiply it by 5, that is going to be a total of $13.50, right? So this right here would be an equivalent rate. Now we can go ahead and write another equivalent rate here. So we know the original rate is $2.70. That was for 3 of these chicken nuggies. But if we wanted to maybe find another equivalent rate, we could also multiply this by just say, I don't know, let's do 12. So if we have 12 times more of these chicken nuggies, then how much would it cost here and how many would we have? Well, 3 times 12, that's going to be for 36 of these chicken nuggies. And then if we take $2.70 and multiply that by 12, then the price should be significantly higher here, right? It should be 12 times higher to be exact. So that's going to be $32.40. And so while we do have 2 equivalent rates here, neither of these are the equivalent rate. So again, this right here is an equivalent rate, and this is an equivalent rate because they have the same value. If you took 370 and divided it by 3, and you took 350 divided by 15, and you took 3240 divided by 36, if they're all equivalent, you should get the same value. But what's the unit rate going to be? Well, the unit rate is going to be per one of something, right? So we want to really know what is 1 chicken nugget going to cost us. So how do you get that? Well, if we want to show that, we just take the original value or original rate here of 270. That's for 3 of these chicken nuggies. So this is going to be my unit rate work here. And we need to get this to be per one of something, right? That's the definition of a unit rate. So how do we get it per 1 chicken nugget? Well, we're going to go ahead and divide whatever the denominator is, right? So we can get 1 on the bottom. Whatever we do to the bottom, we're going to do to the top. So if you take 270 divided by 3, that's essentially like 27 divided by 3. So that's going to be 90 cents here. So if we have $2.70 for 3 chicken nuggies, then it would be 90 cents for 1 chicken nugget. So in terms of the unit rate, that would be this right here. It would be 90 cents for one of these chicken nuggets. So this right here would be the unit rate. And these would be two examples of equivalent rates. All right, let's try another one together. In example B, we see that Nick is going to tell 8 jokes in 5 days. Now, typically we're going to do things per day. Maybe you could do per joke too. So rates can be written either way, but I think it makes more sense to make it per each of these days. So what I'm going to do is just write that we have 8 of these jokes on top. And we know we're going to be telling these at a rate of 8 jokes every 5 days. So we're going to put 5 days on the bottom here. So we're comparing these two quantities. Now feel free to play around and be adventurous with some different values here. Let's just say we have 3.4 times more amount of days that are going to go by. Then Nick should tell 3.4 times more jokes, right? All right, so 3.4 times 5 means that we're talking about 17 total days are going by. So it's a lot more time, so he's going to tell more jokes. And 8 times 3.4 is going to be 27.2 jokes. So he's not going to quite make it through telling his 28th joke. Maybe he gets cut off a little bit, but maybe on his 18th day, he'll get through that joke, right? And so this right here would be an equivalent rate. Now, if we take that same original rate here and we want to create another equivalent rate, again, multiply by anything you would like to. Maybe we could do something like multiplying this by 1/2, right? So we can multiply by fractions, by decimals, anything like that's going to be okay, as long as we do the same thing on top and bottom. So what's half of 5? Well, half of 5, I don't need a calculator for that. I can just say that's going to be 2.5 or 2.5 days. So if he has half the amount of time, he should be able to tell half the amount of jokes. So half of 8 is going to be 4. So it's going to be 4 jokes in 2.5 days. So that's going to be the same equivalent rate. So here we have two equivalent rates, and of course you could multiply by other numbers or even divide by other numbers as well. But let's now go ahead and see if we can create the unit rate now. So what's the unit rate going to be, right? What do we have to get in the denominator, or what does it have to be per? Well, hopefully you remember from our example just a moment ago that unit rates have to be per one of something. So we're really wondering how many jokes does Nick tell in 1 day? That's called the unit rate, right? So how do we get 5 days to become 1 day? Well, you could multiply it by 1/5, or we can just divide by 5. That's probably going to come a little bit easier or make a little more sense. So if we do that to the bottom, we should do that to the top as well, right? So if we take those 8 jokes and we divide them into the 5 days, then how many jokes is he going to tell per 1 day? So 5 goes into 8 one time with 3 left over. So we can say it's going to be 1 3/5 jokes, all right? So that's how many he would be able to tell technically in 1 day. And if you wanted to and you prefer decimals, I think this one's fine to do just because it doesn't end up being a decimal that's non-terminating. So 1 3/5 is also the same thing as 1.6. So these are equivalent, right? So depends on the situation, but these are both going to be okay here. So whether you want to write it as a fraction or using a decimal, we're going to have unit rates here because it's per 1 day. Let's try one more together here. So in example C, Alina is going to be drawing 18 pictures in 4 hours. Just like in example B, we typically put time on the bottom because it's per 1 hour. That's a pretty common rate that we would do. You could see how long it would take to draw one picture, and that's also perfectly fine. But typically, again, we're going to do it per hour. That makes a little bit more sense because especially if we talk about independent and dependent variables, we typically do things per time anyway, right? So the original rate here is going to be 18 pictures. So she's going to be drawing 18 pictures in how long of time? Looks like it's going to be in 4 hours. So I'm just going to go ahead and write that original rate down. And so once we have that original rate, we can just go ahead and create some equivalent rates here. So again, we can multiply or divide top and bottom by any value we would like here. That's going to create an equivalent rate. So let's try dividing this time. So let's divide both top and bottom by 2. If we go ahead and do that, that's half the amount of pictures. So let's go ahead and just draw. This is our fraction bar to help us write our rate here. This is going to be 9 pictures in how long of time? Well, if we draw half the amount of pictures, it should take half the amount of time. So we should have 2 hours here instead. So this right here would be an equivalent rate. Now let's try getting another equivalent rate that's maybe not the nicest looking, but just to try so we get used to working with some other types of rational values or fractions or decimals here. Let's try dividing both by 3, even though it doesn't work so nicely for the denominator value here. So if we go ahead and take this 4 hours and divide by 3, it doesn't go in nicely, right? But we could say that would be 1 1/3 hours, which would just be 1 hour and 20 minutes. So the question is how many pictures could Alina draw in 1 hour and 20 minutes? The top actually works out nicely here. So 18 pictures divided by 3. That means she has 3 times less amount of time. So she would draw 3 times less pictures. So that would be 6 exact pictures in 1 hour and 20 minutes, or 1 1/3 hours. All right, so we have our two equivalent rates, but what about specifically a unit rate? Well, we haven't done that quite yet, so let's do that now. Remember, the unit rate is going to be per one of something. Now, where's that one going to be? If you look at our last couple examples, that one is always going to be on the bottom here, right? It's going to be per one of something, so we want it to be per 1 hour. So we can always set it up just like this. Now, how do we get from 4 hours to 1 hour? Well, that's 4 times less the amount of time, so you could multiply it by a quarter or just divide top and bottom by 4, right? Now, if you take 18 and you divide it by 4, you're going to notice it doesn't go in nicely, but it's going to go in 4 times with 2 left over, and 2 out of 4 is just a half. So you could say that Lena is going to draw 4.5 pictures, or again, you could write 4.5 if you would like to, but hopefully you get the point there. I'm just going to write 4.5 pictures per hour. This would be Alina's unit rate of drawing 4.5 pictures per 1 hour, and it's a unit rate because it is per one of something. So at this point, hopefully you feel more comfortable on how to create an equivalent rate. Again, you can just multiply or divide the numerator and denominator of the rate by the same value. And then you can also get the unit rate if you can specifically get that second or bottom number to be 1, right? That would be a unit rate. Now that we hopefully understand that a little bit better, let's try filling in a rate table and also graphing a rate. All right, so in this situation, we see that Yael is going on a road trip and is going to cover or drive 552.5 miles in a span of 8 hours. So let's go ahead and write that rate down, the original rate here. So it's going to be 552.5, and that's going to be miles. I'm going to use MI to abbreviate the miles, and that's going to be in a time span of 8 hours. So I'm going to write HR for 8 hours here. All right, so that's going to be the original rate that we're given. Now we have this empty table. All right, so typically with these rate tables, we're going to start with 0 and 0, just because if you have 0 time, then you can't drive anywhere. So it's going to be a starting value of 0, right? Now let's go ahead and see if we can figure out some other values here. We can go ahead and start with the unit rate. That's always typically a good place to start. So let's go ahead and find the unit rate here. So what if we want that to be just per 1 hour, right? For a unit rate, well, to get 1, what would we have to do to the top and the bottom? We would have to either multiply top and bottom by 1/8 or divide top and bottom by 8. So you can go ahead and throw that into a calculator or do it by hand, but we should end up saying that that would be 69, and I believe it's going to be 1/16 miles. Okay, and that's going to be the amount of distance you're going to cover in 1 hour. And so now that we know what that unit rate is going to be, we're going to say in 1 hour, Yael is going to cover 69 and 1/16 miles in that amount of time. All right. Now that we know this unit rate, we can go ahead and figure out any other value. So typically what we can just do is say, let's figure it out for 2 hours. How far would they travel? And then 3 hours and then 4 hours. And you can go and create as many of these as you would like to, but I think we're just going to just do this and that would be fine. But let's go ahead and create some equivalent rates now. Like, let's go ahead and say, let's go for 2 hours. So let's multiply top and bottom by 2 here. If you do that, then 1 hour times 2, that would be 2 hours, right? So go ahead and put 2 hours on bottom. Now, if we double that 69 and 1/16 value, you can go ahead and use a calculator if you'd like, but you're going to end up getting 138, I believe, and 1/8. Hopefully that makes sense. It should be end up with an 1/8 here, just because if you double a 16th, you end up with an 1/8. So in 2 hours, we would expect Yael to be having traveled a total of 138 and 1/8 miles. So what if we now want to figure out how far they travel in 3 hours? Well, let's just go ahead and multiply by whatever value gets us to 3. So let's multiply by 3 on top and bottom, and notice that that's going to get us 3 hours on the bottom of this rate. And if we take our 69 and 1/16 and multiply that by 3, it's going to be a total of 207 miles, and I believe it's going to be 3/16. So it's going to be 3/16 of a mile, right? So I'm going to go ahead and put that in our table. That's going to be 207 and 3/16 of a mile. And hopefully the 3/16 makes sense, because this ends up with 1/16. This is technically 2/16, and this will be 3/16. So for the next one, we should expect it to be 4/16, which is really just a quarter. All right, so for one last equivalent rate here, what if we're going for 4 hours? Well, again, you could do a few different things. You could have just taken this original thing and divided it by 2 to get 4 hours, but we're just practicing using our unit rate here. So we can multiply our unit rate by 4 on top and bottom to get another equivalent rate here. So if we want to get it for 4 hours, let's just go ahead and multiply top and bottom by 4. And 69 and 1/16 miles multiplied by 4 is going to be a total of 276 and a quarter mile. So again, that's going to be 4/16, but you can simplify that down to 1/4. So this is going to be 276 and 1/4 miles. All right, so now that we have a table of values, let's go ahead and plot this on a graph. So again, our top row of our tables is always going to be along our x-axis. That's going to be our independent variable, which hopefully makes sense because time will be our independent variable. And then the number of miles depends on that because it's how far we're traveling in that amount of time. Let's go ahead and put the miles on the y-axis. So let's go ahead and label that on our graph here. So first things first, let's go ahead and just label a few things. So we have the number of hours along the x-axis. We have the number of miles along the y-axis, and we throw on a title at the top of this graph. I'm going to call this Yael's road trip. All right, so here we have our x-axis, we have our y-axis. Let's go ahead and see if we can start spreading out our table a little bit here. So we had to go from 0 to 4, if you remember from earlier. So let's see how many boxes we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 boxes here. So we have to go from 0 all the way up to 4. 12 divided by 4 means we could go every 3 boxes if we wanted to here. So every 3 boxes, I'm going to make just going to be 1 hour. Then every 3 boxes, that's going to be 2 hours. Then this is going to be, that's going to be 3 hours, and then this is going to be 4 hours. So I'm basically saying that each of my boxes is worth a third here. So I'm going to say this is going to be times 1/3, right? Every box is worth a third, or every 3 boxes I'm saying is worth 1. Now, if we go along our y-axis, we need space for 4 of these values here. So we can just jump by the 69 and 1/16, so whatever that unit rate is here. So this will be nice, hopefully, if we just go ahead and choose this. Value is going to be 69 and 1/16. So I'm going to write, it's going to be a little tricky because I ran out of space here. So 69 and 1/16, that's going to be for this value right over here. I'm going to squeeze that in. And then for, let's go ahead and jump 3 more up here. So I'm going to say that's going to be 138 and 1/8. So where am I going to put this? 138, I'm going to put it on the side here. 138 and 1/8. So hopefully we can plan out a little better for this in the future. And then over here, I'm going to say that is going to be 207. Let's put 207, and that's going to be 3/16. I'm going to put that right over here. And then finally up at the top, this is going to be our 276 or 276 miles and a quarter. Right, that's going to be right over here. All right, so applying our points hopefully isn't going to be too bad because in 1 hour we're traveling 69 and 1/16 mile. In 2 hours we're saying it's 138 and 1/8 mile. And then for 3 hours we said it was 207 and 3/16 of a mile. And then for 4 hours it's going to be 276 and a quarter. So if we go ahead and plot all these, don't forget that at 0 hours we can't travel anywhere. Then just go ahead and draw a nice perfectly straight line just like this. And that would be representing this rate. You can see this point right here would be our unit rate. Then you can see that if we double the amount of time here, that you would double the distance as well. Then if you went ahead and tripled the distance here, that would take triple the amount of time. That would be right over here, and then so on and so forth. But if you went ahead and did 4 times the amount of time, which is 4 hours, you would also go 4 times the distance here. So that would be another equivalent rate. But you can basically use the unit rate here to help us do that. The unit rate is that first one per 1 hour. That can help you find any other equivalent rate a lot easier. All right, so that just about wraps up this lesson on talking about some rates, equivalent rates, and unit rates, and hopefully you feel a little bit more comfortable about how to create a ratio or rate table. And hopefully it made sense that we could apply our understanding of these equivalent rates to make a table or a rate table, and then went ahead and just graphed that on a coordinate plane as well to represent the relationship between those 2 variables of the amount of distance that was traveled and the amount of time that it took to travel as well. I hope you found the video helpful, and as always, keep up the great work that you're already doing.